Hi, in today's video, we're going to start section 3.3, which is log and their graphs, and we're going to look at some properties of log that you guys see here on the screen. First of all, we need to understand what does a log mean in order to understand its properties. And to do so, we're going to compare it with a function that is familiar to us, which is the exponential function. So as you guys see right here, this graph in blue shows an exponential function. It has the equation b to the power of x, and I know the general one that we've worked with is ab to the power of x, but in this case, a is 1, and as we said, a is the initial value, which in this case is what we call the y-intercept. And we look at the log function, which is given in black. It's log base b of x. That's how we read it, log base b of x. So first we're going to make a table, and we're going to compare log and exponential. And we're going to compare a few features. We're going to compare the domain, the range first. And the domain is we read left to right and we read the x value. And if we do that with log, the most left start right here but doesn't touch it. So 0 with parentheses. And the most right is infinity. For exponential, most left is negative infinity to most right is infinity. The range we read bottom to top. So for log, we read the y value bottom to top, negative infinity to infinity. For exponential, the bottom, the lowest part is 0, not touching it, all the way to infinity. So we can see now the relationship, how domain of one is the range of the other one. They're switched around, and the range of log is the domain of exponential. Let's continue with this comparison, domain, range. We're going to talk about asymptotes. And for log, the asymptote is the barrier. It's that line that the graph approaches to but doesn't touch it. It's the y-axis. For exponential, we can see that it's the x-axis. The x-axis has the equation y equals 0. The y-axis has the equation x equals 0. The last thing we're going to look at is intercepts. We just talked about the y-intercept of the exponential function. And if we look at the log, it doesn't have a y-intercept, doesn't cross the y-axis, but it does cross the x-axis. So we can see that a relationship of x switched with the y. And this relationship, we talked about it when we worked with inverse functions. That was the first step in inverse functions, switching x and y. So in this case, if we switch x and y, that means the log and exponential are inverse of each other. That is the relationship. So if exponential is an exponent with exponential function, so I'm going to give you an example. If I say 3 to the power of 2, this is an, for example, 3 to the power of x, but let's say x is 2. So the input is an exponent. What we're going to see with the log is that the output is an exponent. And let's apply this right away. You need to understand how to say it in words so you can understand the properties. So if you look at A, it says log, I'm rewriting it big just so you can see it, and it's important to read it. Log base 2 of 8. So the base is what we see, the number that we see right here. What does this mean? This means which power or exponent should 2 have to equal 8? And in this case, which power should 2 have to equal 8? It should have a power of 3. So 2 to the power of 3 equals 8, which means this is the output of that log function. Now, there is something called the loop rule. It's like a trick that helps us check that what we did is correct. And look what's going to happen. This is the loop. 2 to the power of 3 equals 8, which is a correct statement. Now, for the other ones, we're going to see how B is asking for log base 3 of square root of 3. You guys need to understand how to convert between a radical form and exponential form. This was done in Algebra 2, but we'll remind you. Radical form, the inside is an exponent, the outside we call it index. The inside goes on top, the outside goes on the bottom. So x to the power of half equals square root of x. You need to understand that. That's if you have, for example, cube root of x to the power of 2, it will be x to the power 2/3. When we see log base 3 of square root of 3, I need to rewrite square root of 3 as a 3 to the power. And since it's a square root, it's a power of half. And if I look at this list of rules and I number them, I like to number the rules so I can refer to them nicely. Rule 1, 2, 3, 4, 5. If I look at rule number 4, it's the same as this. Log base 3 of 3 to the power half is just that exponent.